When you're starting.
Hello, Joel. This is our Monday edition of Pre-Calculus. It is December the 9th.
7.
And today's the 7th?
My mom's birthday's tomorrow.
My dad's birthday's today.
I thought yesterday was
Emily
8th.
Martin's birthday is next week.
Whoa, I'm off base. That's right. What was it? This day will live in infamy. That is, it is the 7th. I'm sorry. I put the wrong video number, I think, on part 1. So if I have the wrong date, please forgive me. All right, so you're going to be watching a video tonight. So this is a short teaching now because we didn't do one over the weekend. We were finishing up our test and thinking on that rather than something new. So we're back into video land regularly now. And this is called the Law of Sines. So take in your comp book and title it The Law of Sines. And you've actually had this in geometry, so hopefully it'll go fast. Let's develop it. Give yourself a triangle. The only requirement is not a right triangle. So can you see that my triangle is not a right triangle? Remember, a right triangle has an angle that looks like that somewhere in it, a right angle. So notice this is not a right angle. There's other choices you could make, but that's the triangle I chose. What's a triangle called that has no right angle in it? No right angle is oblique. Oh, how bleak. Oblique triangle. Is it bleak to you that there's no right angle in it? It should be, because all of our trig is based on a right triangle. We can't use sine, cosine, or tangent unless it's a right triangle. So we are oblique. We are oh so bleak. Oblique triangle today. So we're not comfortable at all. We're nervous, we're upset, we're anxious because it's not a right triangle. So to calm our nerves, we're going to drop a perpendicular right in the middle of the triangle to form, when I drop a perpendicular, it does meet the base with a right angle. So I've taken that oblique triangle and changed it into two right triangles inside of it. I haven't changed, it's still an oblique triangle, but at least I'm a little more comfortable with some right angles now looking at me. Let's call this H for height. Let's put in some other parameters. Let's do A, B, C. I'm going to try to, if you would help me remember, I'm going to try to always letter them the same, because it just helps us get through the problem. If we all have the same letters at the same position, there's no reason why they have to be ABC in this direction. So let's just say the triangle is sitting on its abs. So is there some kind of exercise where you lay on your stomach? Yeah. So this will help me remember. I'm going to put the abs on the bottom and C on the top. All right, what else do I need? There are 6 parts to every triangle. Those are the 3 angles. I'm using capital letters. And across from each capital letter is a small letter representing the sides. Have you seen that kind of notation before in your math past? All right, so we have that going. All right, so no right angles is an oblique triangle, and we've divided it so that it does have right angles in it, and we've called the altitude height, and we put in the 6 parts. What we're doing today is solving triangles. We used to solve equations, now we're solving triangles. All that means is find all 6 parts. And we'll usually be given like 3, and we have to find the other for 3. Find all 6 parts. What I mean by the 6 parts are the three angles, capital A, B, and C, and small a, B, and C, the 3 sides. So we'll be all happy when we got all 6 parts. All right, so let's get to work now. I'm going to develop the law of sines, if you would write it as I do. We're going to notice, since we're only going to work with a right triangle, I'm going to take the right triangle within this oblique triangle on the left. And I can say that the sine of that angle equals something over something. Fill that in, since you are well trained in trig now. Looking only at the striped triangle, it is a right triangle within the oblique triangle, and I want the sine of A, something in this triangle divided by something. Did you write, knowing that sine is opposite over hypotenuse, did you write opposite A, H, over hypotenuse, B, which is always the side across from the right angle? Did you get that before I did? Hopefully. Let's solve that for H by multiplying both sides by B. The B can hop over here and be equal to H. All right, so now I'm going to do the same thing to the other side. And the candy cane striped triangle on the right, in keeping with the theme of the day. So let's look and see what that is. Now I want the sine of angle B is something divided by something. So look at the striped, they're both striped. Look at the pink striped one. And I'm looking from the perspective of angle B this time. So we have, again, opposite, and we're staying in the right triangle, opposite over hypotenuse, H over A. All right, so now we're going to solve that for H, and we get A, multiplying both sides by A, we get that. So we have A sine, side B times sine of angle A equals H, and side A times sine of angle B equals H. Both these expressions are equal to H, so I'm going to set them equal to each other. If this equals H and this equals H, then they're all the same. So I'm going to pick, doesn't matter which one, I'll put A sine B equals B sine A. You can write it in the other direction and be perfectly fine. A sine B, small a sine big B equals small b sine big A, where big A's are angles and small a's are sides. Let's go ahead and clean that up, and we'll have the law of sines. The development was really quick. Let's get what most books do. Let's divide both sides by A first. And we do that, notice the A's become a 1 over here on the left. A divided by A is a 1. When I was taught to teach math, they said you never use the word cancel. I do sometimes, I slip up. But I guess canceling seems to indicate to the student that it's gone, but it's not gone. It's just A divided by A is 1, and 1 times sine of B is just sine of B. So it isn't gone, but its effect is 1. All right, now I want to divide both sides. So I have this. I want to divide both sides by B now to get this. So this B over that B is another 1. So I have sine of angle B divided by baby B equals sine of angle A over sine or baby A. All right. If I was going to take the time to redraw another, I can't do the sine of angle C because the altitude or height goes right in the middle of it. But I could do it from the perspective of this side. So I could drop let me switch. Do we have green for festive effect? If we dropped a perpendicular from A over here and made 2 right triangles on this side, we could do the same thing with C, and you would find out that this pattern continues. So I'm not going to take the time to convince you of that. You may convince yourself of that. All right, so sine of B over little b, sine of A over little a equals sine of C over little c. Does that look familiar? It's not the law of sines. That is it. So let me show you how to use it. We developed it. How many minutes are we, Victoria?
9 minutes.
Okay. So somewhere between around 11, 12, we'll shut it down and start part 2. So it doesn't take so long to upload. Yeah. So, all right. Sorry, I hope you didn't need that. Should have paused a little longer. You have to look at the video if you need it. All right. So the law of sines is this. I will write it in its normal glory with sine A first. Does not have to be. They can be in any order. Also, this looks top heavy to me, so it's okay if you flip them. So I like the inverted form, but you can use either form. So I'm gonna flip it to show you what I often use, but proportions are like that. If you don't like the way they look, you can turn them upside down as long as you turn everything in the proportion upside down. Does it confuse you or surprise you that we have two equal signs in the law of signs? Because normally we have a proportion with two parts. How do you use a proportion with three parts like this? We won't use three parts. We will either use these two, or these two, or these two. So we're not going to use three at once. So I never did learn to juggle, did you? So, all right, so we're just going to use two at once. I can juggle two things. Can you? You juggle two things? Let's see. All right, here we go. Look at that. All right, put a third one in. No go. Anyone do three? Nobody? Untalented class. I always have one that can do that. Joel, you have to learn and show us tomorrow. All right,
Okay,
ready?
we should probably stop it.
Okay. Good stopping point.
20 seconds.